Case 2 deals with side-side angle triangles. With side-side angle triangles, the resulting triangle can either be one triangle, two triangles, or no triangles. Although formulas exist for identifying which type of triangle we're dealing with, the law of sines automatically provides us with the appropriate results. Let's go through a few examples. Here we have a side-side angle triangle where the angle alpha is known, the side opposite the angle alpha A is known, and we know the length of the side opposite beta. Therefore, the first thing that we need to do is find the angle beta. We can find the angle beta by saying the sine of beta over the side opposite beta, B is 2, equals the sine of alpha, 40 degrees, over the side opposite, 3. That means that the sine of beta is going to equal 2 times the sine of 40 degrees over 3. If I enter this expression right here into my calculator, I get that the sine of beta is about equal to 0.43. Be sure that you store this result in your calculator's memory so that you're not using approximate values. When you use approximate values, your answers become slightly off. Now what we're going to do is find the value of beta. We find the value of beta by computing the inverse sine of both sides of the equation. Remember that the angle beta can be any answer or any angle between 0 and 180 degrees. Therefore, because the sine function is positive in both the first and second quadrants, there are going to be two angles whose sine is 0.43. The calculator will give us one of the angles when we compute the inverse sine. The calculator gives us that beta 1 for our first guy is approximately 25.4 degrees. Then, to get the other angle in the second quadrant, just take 180 degrees minus this quantity. So beta 2 is going to be approximately 180 degrees minus 25.4 degrees is 154.6 degrees. We know that this is impossible because of the fact that our angle alpha is 40 degrees. 40 degrees plus 154.6 exceeds the sum of the values of the interior angles, 180 degrees. So we rule that out as a possibility. Therefore, there's only going to be one triangle which has these as its measurements. So beta 1, or beta, is about 25.4 degrees. We can then find gamma, knowing that gamma is going to equal 180 degrees minus alpha minus beta. We get, then, that gamma is equal to 114.6 degrees. Now what I need to do is find the value of C. We can find the value of C using the law of sines. The sine of 40 degrees over 3 equals the sine of 114.6 degrees over C, where 114.6 degrees is this one up here. We then solve for C. We get that C is going to equal 3 times the sine of 114.6 degrees over the sine of 40 degrees, and we get that C is approximately equal to 4.24.